Hey everybody. I don't think I said this on the last video. In fact, I know I didn't say it in the last video because I just did it like 5 minutes ago. This assessment will be the last assessment that you'll take in Algebra 2. Obviously there's only 2 weeks left, so we're going to do this 3-1 and 3-4 quiz, and then next week we're going to have sections 3-5 and 3-6. But we thought rather than try to put a quiz on there on Friday, we're just not going to quiz. Give you guys a little break. Use that to, geez, my hair's all messed up. Use that to, that time that we would spend taking a quiz, use that time to tie up any loose ends that you have with my class. And I'm taking any late assignments, so if you want to turn in anything, send them my way. All right, so this is a video going over the review assignment. Okay, so it's the key to the review assignment. It's this key, the quiz review key. This unit circle is, I mean, it looks like exactly like, I think I just copy and pasted the page from the quiz to this review of the unit circle. So you'll see the exact same thing on your quiz. Please use this unit circle. Please do not use a different unit circle. I just want to make sure that you have one that only has the things you're allowed to use. All right. So let's get to it. All right. Get my face out of there. Use the special right triangle rules to find the exact value of x. Okay, so this is a 45, 45, 90. Since it's the hypotenuse is 80, I'm going to take 80 and then divide it by the radical 2, which when I rationalize is 80 radical 2 over 2. So 40 radical 2. Yeah. Okay. Number 2, a surveyor whose eye level is 6 feet above the ground determines an angle of elevation to the top of an office building at 38.5 degrees. Okay, picture time, everybody. Picture time. Here is a surveyor. Little known fact. When I just graduated high school, I worked as a surveyor's assistant. Okay, I wasn't really the guy that looking through the machine, but I was the guy doing all the grunt work, carrying all those sticks everywhere, and like writing on them and putting little flags on them. Okay, so here's my picture. So a surveyor whose eye level is 6 feet above the ground. So we know that this is 6 feet above the ground. Kind of like me, I'm like 6'3", 6'4", right? So eye level is 6 feet above the ground. Top of an office building is 38.5 degrees. 38.5 degrees. There's my theta. And if the surveyor is standing 50 feet away from the building, how tall is the building? How tall is this full length of the building? All right, so let's find x. And x is this distance in here. Should make note that it stops right there. Okay, so I know that this is 38.5 degrees, my angle, and this is the opposite, and this is adjacent. So I want to use tangent of 38.5, and that's going to be equal to x over 50. Cross multiply 50 tangent 38.5 is going to be equal to x, which is 50 times the tangent of 38.5. Let me just double check that I am in degree mode and not radian mode. Okay, good. Come on, get out of there. Get out of there. 38.5, 39.7 centimeters. Let's go 40 feet. 40 feet. Okay. Now, the only catch is, don't forget, I want the full height of the building, so I've got to add on this 6 feet, which matches over here from the eye level. So total 46 feet altogether. Okay. 3, 4, and 5. Okay. Here's 3. Draw an angle in standard position of 635 degrees. Okay, here's my initial side. My terminal side is going to be, okay, we got 360. Okay, 360 minus 635, take away a full rotation, is going to give me 275 left over. Okay, so I know that it's 360 and then an additional 275. So this is 90, 180, 270, then 5 degrees more. So if I want to do my spiral, you don't have to. It would help. Whoa. Don't do that. Here. Whoa. Don't do that. Here, around, and then 5 degrees more. Oh my goodness. There. So 5 degrees more into there. Here we go. Yikes. What in the, where did my pen go? There it is. I'm gonna leave that one alone. Sorry about that box around there. Find the measures of the positive and negative coterminal angle of negative 320 degrees. Okay, so negative 320 degrees, that's gonna turn into, okay, if I add 360, why do I not see my pen anymore? Yikes, that's annoying. Okay, now it's back. So if I want my positive and negative coterminal angles, I have to add and subtract 360 degrees. So if I'm at negative 3, oops, that's a subtraction sign. Negative 320 degrees, I'm going to add 360, and that's going to be a positive 40. And then another coterminal angle is going to give me negative, yikes, where did my pen? I can't see my cursor anymore. Negative 320 minus 360, negative 680. Negative 680 degrees. Okay, yikes. Sorry for the poor handwriting there. What's going on with my pen? I can't see that cursor. Whoa, jeez. Okay, sorry. I'll fix this after. Okay, so find the measure of the reference angle for negative 216 degrees. Negative 260 degrees is down here. So here's negative 180. So negative 180 is over here. 260 degrees somewhere up here, I believe. Yeah, because this is, yeah, 216 degrees. Jeez. It's really going to bother me. All right, so now I've got to find the reference angle, right? So if this full rotation, if I'm thinking about it in positives, this is positive 216, right? Going around, can't see my pen, going around this way, right? So if that's 216 degrees worth of rotation, I want to subtract away 180 to find that reference angle. So 216 divided, or subtract away 216, subtract away 180. That reference angle is going to be 36 degrees. 36 degrees right there. Okay, and that's the reference angle, 36 degrees. Okay. Hopefully it just did it on that page. Okay, good. I can see my cursor again. I can write. Yeah, it's going to stay. Okay, good. Okay, point P is a 2 comma negative 3. So here's my, you know what, I want to just use the 2 comma negative 3. 2 comma negative 3. 1, 2, 1, 2, 3, big units there. 2 comma negative 3, there's point P. And there's my, okay, now it says a point terminal side in standard position. Find the exact value of the 6 trigonometric functions with theta. Remember, I want to use my reference angle, right, made with the horizontal. So here is my right triangle that I'm going to use. Sorry. So this is 2, this is negative 3. Okay, I want to find my C value, my hypotenuse. So it's 2 squared plus a negative 3 squared. That's going to be C squared. So 4 plus 9 is C squared. Don't make that a negative 9, please. This is 13 is C squared. Square root it. 13 is prime, so square root of 13. Okay, so let me say that this is square root of 13. And now I want to find sine, cosine, and tangent. And then I want to find secant, cosecant, secant, and cotangent. Okay, so sine theta is going to be the opposite over hypotenuse, excuse me. Negative 3 over radical 13. negative 3 over radical 13. And when I rationalize, it's negative 3 radical 13 over 13. Cosine is adjacent 2 over radical 13, hypotenuse. So when I rationalize, it's going to be 2 radical 13 over 13. And tangent is opposite over adjacent 2. Now when I go to do the reciprocals, cosecant is going to be radical 13 over negative 3. Cosecant was that. Secant is going to be radical 13 over 2. And then cotangent is going to be 2 over negative 3. Okay, those are my answers there. All right, here's 7, 8, 9, and 10. Okay, converting from degrees to radians and radians to degrees. Remember, that's the pi over 180 or 180 over pi. In this case, it's I'm going to multiply by 180 over pi. Get the pi out. Cancel out there. And then so we're just going to take 17 times 180 and then divide it by 5. 612 degrees. Use your unit circle to find the exact value of tangent of 240. So I'm going to go to my unit circle. Didn't I just have it up? Yeah, right here. 240. Where's 240? There it is. So it's the exact value. So I want negative 1/2. So it's third quadrant, negative, negative, 1/2, comma, radical 3 over 2. 1/2, comma, negative 1/2, comma, negative radical 3 over 2, right? So if I want tangent, it's y over x, negative radical 3 over 2, divided by negative 1/2, which gets me negative radical 3 over 2 times negative 1/2. Oh, excuse me, reciprocal. Keep change, flip. 2 over 1. Cancel the 2's. Negative times negative is positive. Right, that was negative. So it's just radical 3. Okay, that's my answer. Yeah, no decimals when I say exact value. Okay, find lowercase sine. State my answer in radians. All values. Find all values. That means I've got to add in my 2 plus 2 pi n. So y value being radical 3 over 2. I want to find where the y value is radical 3 over 2. And I believe they're right here. So pi over 3 and 2 pi over 3. See the y values at radical 3 over 2? So pi over 3 and 2 pi over 3. Pi over 3 and 2 pi over 3. So I say plus 2 pi n, where n is an integer. Okay. Those are my answers. Evaluate inverse trig function capital S sign. So remember the capital S sign being, I know that that's going to restrict to first and fourth quadrants, negative 90 to positive 90. Right? All right, negative radical 2 over 2. So since I know sine is going to be negative here, I know that it's going to be down here. So I'm going to have to do something a little funky with the angle measure. So I go back to my unit circle. Negative radical 2 over 2 with the y value is right here. So 7 pi over 4. You know, think about the other coterminal angle. Isn't that negative 45 degrees or negative pi over 4? That's what I'm looking for there. So negative pi over 4 or negative 45 degrees. Don't give me 7 pi over 4. Don't give me, what was it, 315? Yeah, I don't want that because that's not within my domain. My domain is, since it's capital sine, negative 90 to positive 90 or negative pi over 2 to pi over 2. Right? It's got to fit within that domain. Okay, here's 11. 53-foot telephone pole casts a 64-foot shadow. Okay, so here's the telephone pole. Here's my shadow. 53 and 64. I want to know this theta, right? So tangent theta is equal to the opposite 53 over the adjacent 64. So inverse tangent, yeah, I'm switching to capital. 53 over 64. So I'm going to go here. Inverse tangent. 53 over 64 gives me the nearest degree. Yeah, 40 degrees. Okay, I'm going to solve this equation for theta. So inverse sine of 0.6 okay, is 36.9 degrees. But that's not within my restriction. So I think about, okay, so if sine, say this is 1, right? If sine is 0.6 somewhere in here, a little bit more than halfway, I know that this is an angle and that this is an angle, right? So here's my sine value, and I know this is the y value, right? Because I'm talking about sine. If it was cosine, we'd be thinking about x value. So here's the same angle measure there, right? Same reference angle. So I take 180, I subtract away 36.9, and that's going to give me this equivalent angle. So 180 minus 36.9 going to give me 143.1, which is within my restriction. Okay, last one here. Carpenter is designing a curved piece of molding for a ceiling of a museum. The curve will be an arc with radius of 4 meters. I know I have to use the equation S equals R theta, but theta has to be in radians. So I've got to just convert this 140 to radian measure. Okay, so it's, just canceling out the zeros, 14 pi over 18, so 7 pi over 9. So S equals 4 times 7 pi over 9. So I go to here in my calculator. 4 times 7 pi divided by 9. 9.8 meters. All right. Again, quiz is going to be tomorrow. Those of you taking the A-Push test, good luck on your A-Push test on Friday. Yeah, hopefully we're all staying happy and healthy. See ya.